Hey, so welcome to part 2 of our notes on ionic bonding. So we're picking up where we left off with this first video and talking about what ions are, and we're going to learn how these ions interact with each other when they come in contact. So to begin, we just need to get a few ideas down about ionic bonding, some of the characteristics that you can see take place every time there is an ionic bond. First of all, they are formed between metals and nonmetals. And then just to review from our unit on the periodic table, metals are on the left side and nonmetals are on the right side. So we're looking at opposite ends of the periodic table coming together to make bonds. When we have ionic bonding, this involves gaining or losing electrons. That's the whole way ions are formed in the first place. So the negative ions and the positive ions are attracted to each other, and as they come together, they form bonds. So this is very similar to the idea that opposites attract, kind of like the opposite ends of a magnet attract each other and they pull towards each other and connect. The same concept goes into ionic bonding. Once a compound is formed, the overall compound is neutral because the negative charge and the positive charge on the ions end up balancing each other out. So everything ends up being the same amount of plus signs as you would see negative signs. So some other properties that identify what type of bond takes place when we look at an overall compound or the substance. The substances of ionic bonding have high melting and boiling points. That means it takes a lot of energy to get the particles to move away from each other and to start speeding up in their motion. They also have crystalline structures in the way that they arrange themselves as a lot of the molecules come together to make the larger substance that we can see with our eyes. They have high conductivity, which means that they do a really good job of conducting heat and electricity, and they also have stronger bonds. So magnets, sometimes the strong magnets are really hard to pull apart, so you can just think about that concept when you apply it to ionic. So look at this section titled Forming Ionic Bonds. You see Na, which stands for sodium, and it has a +1 charge because in order to be like the noble gases, it's going to lose one electron and its overall charge will be positive. And so this picture at the top demonstrates that. Then sulfur has a -2 charge because it gains 2 electrons so that it would be like a noble gas. So if I wanted to make a bond between sodium and sulfur, what I would need to do in order to make this plus and negative charge cancel each other out, if I put them together right now, and I have one Na and one S, if I add up those two charges, my goal is to get 0. But if I put a +1 and a -2 together, I'm still not going to have 0 yet. So I need to think to myself, what can I do in order to get the plus charges to cancel out the negative charges? The easiest thing to do would be to bring in a second sodium that has a +1 charge, because when we put those plus charges together with the minus charge as a compound, they would cancel each other out. So when I write this in terms of a formula in the compound, I'm going to use subscripts to show how many I have. So I've got sodium, and I have 2 of those, and I just have 1 sulfur. So when I put sodium and sulfur together in a compound, this is how many I would need in order to make things cancel out and be balanced. So a really easy trick here is to think of it this way. I'm going to write this a little bit further down. I've got Na, again with a +1, sulfur with a -2. Easy thing to do is take the number of the charge and switch the places for the subscript. So the 1 from the Na is going to go next to the S, and the 2 from the S is going to go next to the Na. And when we have 1 as a subscript, we don't need to write it. So it ends up looking just like that, or like the giant compound that you see right there. So when we switch the charges, we're not going to worry about the signs. We're ignoring the signs. We're just taking the numbers. And the 1 is understood. Remember, if I take the sign with it, it doesn't make sense to have a negative amount of something, and the subscript is telling me how many I have. So we're going to try a few of these. First, I've got calcium. So what I need you to do is get your agenda out, or once again, if you're on the computer looking at this, you can pull up a periodic table on your computer, and I'd like you to find where calcium is. You should see that it's in the group 2, and we learned that group 2 elements are most likely going to lose 2 electrons, and so their sign or their charge will be +2 when they lose 2 of the negative charges. Oxygen is on the opposite side. It is easiest for oxygen to gain 2 electrons. Remember, electrons have negative charges. If I bring 2 negatives in, I'll have a -2 charge. Okay? So remember, calcium symbol is Ca, and oxygen symbol is O. Now, if I put +2 and -2 together right now, you have to ask yourself, would that cancel each other out? And your answer should be yes. So really, I just need one of each. So I'll have Ca and then O. And that's all you have to write. Okay? Now, lithium and sulfur. Lithium is in group 1. And so group 1 elements are most likely going to lose an electron. So that means they'll have more protons than electrons. They'll have 1 more proton. Sulfur is in group 16 with oxygen. And so it's most likely just going to gain 2 electrons, which means it's bringing 2 negative charges in. All right, so now if I put +1 and -2 together, we're not going to end up with 0. So I'm going to take the 2 from sulfur and put it with lithium, and take the 1 from lithium and put it with sulfur. I'm going to do this little switch. And when I write out my formula, my compound formula, I'm going to put these numbers as subscripts. That means it's going to be lower. So LIS, and I don't need a subscript for S because that 1 is implied. Finally, we'll do magnesium and chlorine. So magnesium is in the same group as calcium, so it has a +2 charge. And chlorine is in group 17, the halogen group, and it's 1 step away from the noble gases, so it will have a -1 charge. So all it has to do is gain 1 electron to be like noble gases. Again, I'm going to take the 2, put it with chlorine, take the 1, put it with magnesium, so I'll have MgCl, then 2 is my subscript. So when we name ionic compounds, we're going to start, it's going to have like a first and last name, kind of like people. So to name an ionic compound, we're going to start with the name of the positive ion, which is the first one. It's usually a metal. It's a positive charge, okay, or positively charged polyatomic ion, which is the list that you had in the first video. So we'll start with that name. It'll stay the same. Then, if the negative ion is an element, we're going to take the ending of that element name and drop it and switch it out for IDE. If the negative end is polyatomic, we'll just leave it the same. So just kind of think about a woman getting married. A lot of times women will change their last name to be the same as their husband's, and so the first name would stay the same. So I'm not married yet, but when I do get married someday, I'm not changing my first name. I'll change my last name. And so the same idea will go into how we name ionic compounds. So some examples here. I have sodium and chlorine. Sodium stays the same, but chlorine, I drop the INE and I switch it out for IDE. For potassium and bromine, when they come together into a compound, potassium is the first name, it stays the same, and bromine switches out for bromide. Finally, I have calcium, and then I have phosphate. Because this is a polyatomic ion, it's made up of more than 1 element, but it acts like 1 atom. This one is actually going to stay the same, because sometimes women don't change their name after all, and that's okay. So this ends our notes on ionic bonding. We're going to do a little bit of review with this when we come back to school, and then we'll have a lab to do after we've had plenty of practice with doing this. So if you're a little confused, why don't you write down a few questions to bring into class when we're back together, and you can address them in class with me, and hopefully we'll get you all set up so we're ready to do the lab. Hope you have a great long weekend, and I'll see you later.